How's it going, everybody? Thanks for coming out. Really appreciate you guys coming to this event. If you don't know already, there's pizza and beer over here, so have at it. Before we get started, I want to say a big thanks to Perfect Circuit for having us out. We've been planning this event for a few months, but the date didn't always pan out, so it's great to see it come to fruition. I'm here to talk to you guys about the two latest Qubit releases, the Chord and the Wave. So we're going to start with our latest release, which is the Chord. For those of you who don't know, it's a polyphonic oscillator which harmonizes 7 chords. So it has 4 individual outputs which are all tuned to the root. So it's a polyphonic oscillator, but it's really musical and tonal in nature. And the really special thing about it is the way that it tunes itself and is musically intelligent. A little bit of background. The Chord has been the longest development time that we've had of any module to date at Qubit. We made the first inception about 3 years ago, and it was alternate firmware actually for the module, the Nebulae. If you guys don't know, the Nebulae was our first module we ever released. It was a sample player, a granular sample player, and it could also run C-Sound and pure data code. So the first version of the Chord that I made, it was just a C-Sound file that just made 7 chords all mixed down to a single output, and it really sparked my imagination and helped me realize that there was something worth pursuing there, something really special about having tuned chords in the modular. Because it's not that you can't get tuned chords in the modular, it's just that it's so hard that you rarely do it, or at least personally, I would rarely do it. And once you have it, it's hard to sequence it to get chord progressions. So the next step for me, we made a analog version of the Chord, 4 analog oscillators, and this is the version that we showed at NAMM this year. I'm sure many of you guys saw that prototype. It was really amazing. It sounded incredible, but it had a lot of problems with the tuning. So being analog, it would go out of tune across multiple octaves. And it was just hard to get the voicings correct, which was really a big issue with it. So from there, we decided we had to do a complete redesign, make it digital, which we didn't want to do from the beginning, but in its final inception, I think is actually one of the most special parts about the Chord is that it's digital, and was able to retain the sound quality that we were hoping for. But the really special thing about making it digital was we were able to get smooth morphing between all of the wavetables with 16-bit resolution. So there's 65,000 steps between 4 waveforms that are coming through the outputs, which allows you to get these just amazing waveforms that you really can't find in any other place. So let's get an overview of it. I'll start showing you guys the features. This is the mix output from the Chord, just going straight to a mixer. Just listening to 4 sine waves tuned to a major 7th chord. So there's 5 outputs on the Chord. You have each individual chord tone and then a mix out. So if we listen to each individual chord tone, this is the root, it's the lowest note in a chord if it's in closed position. The 3rd chord tone, the 5th chord tone, and the 7th. And then once those are all mixed together, they sound like that. So back to the waveform control that I was telling you guys about. It's going to morph smoothly from sine to triangle to sawtooth to square. So as I move the knob, you're going to hear it get brighter, and it's going to sound exactly like opening up a low-pass filter. So like I said, there's 65,000 steps that you're hearing, discrete values in between there. So you're not hearing any clicking, you're not hearing any severe change between waveforms. It's extremely smooth. The next control is voicing. So if you've ever played piano or guitar, you know the voicing is a very special, important part of the chord structure. what the voicing means is it's really the placement of the notes in the octave. And you can have a closed position chord where it's going to go from root to seventh to the top note of the chord in succession. So the root's going to be the lowest, the third, the next highest, the fifth, so on and so forth. And that's what we're hearing right now in our closed voicing. If we go to drop 2, what we hear is the second highest note goes down an octave. Drop 3, the third highest note goes down an octave. And then spread, what happens is the lowest note goes an octave lower and the highest note goes an octave higher. So you can really hear the difference between these, between the drop 3 and the close, or the spread. You hear it spread out. That's exactly what's happening. The control to the right of that is the inversion control. What inversion does is it sets the order of the notes. So whereas voicing determines the octave placement of each note, the inversion determines the order that the notes go in from low to high. In root position, the root chord tone is the lowest, followed by the third, the fifth, and the seventh. In first inversion, the root goes to the top of the chord. You can hear that. If you listen, you hear the lowest note right there, and then it goes to the top. Now the third is on the top of the chord, and now the fifth is on the top, and the highest note in the chord. Quality control sets the tonality of the chord, major, minor, etc. We have what's known as seventh chords, which are chords that are made up of 4 parts. The first chord is major 7. Next chord is minor 7, which just lowers the third and the seventh chord tone. Dominant 7 is a major triad with a lowered seventh, so you hear from minor 7 to dominant 7, the top note stays the same, but the third chord tone goes up a half step, and then half diminished. So these chord qualities are all diatonic to the major scale, meaning if you're in a specific key, if you're in a major scale, all of these notes are found within the key. All of these chord qualities are found within the key, depending upon what your root note is. And we'll get to that next. So the volt per octave input sets the frequency of the root note, and then all of the other chord tones harmonize to that. So if we take our pitch sequence from the octone, which is our sequencer, we plug it into volt per octave, you hear it's changing the root note, which changes all of the notes in relation to it as well. What's happening right now is known as constant structure. We're hearing the chord is changing, the root note is changing, but the chord quality is staying the exact same. And what happens is it winds up sounding dissonant. And the reason that it sounds dissonant is we're hearing notes from outside of the key. Not every note that we're hearing is inside the key, because what needs to happen is the chord quality needs to change so that all the notes fall from the same key. So what we did is we decided to try and make that as easy as possible on the user, and we created the harmonize function. So once you turn on harmonize, chord quality is going to be automatically chosen for you, and it's going to harmonize in the major scale, leading to all diatonic notes. In other words, it's always going to sound pleasant because all of the right notes are going to be in your chord progression. So once we turn that on, the chord quality control is now going to operate on its own. The knob doesn't do anything. And you'll hear sounds very pleasant now. All the notes are happening as they should if you were going to be in a tonal chord progression. The triad button, which is next to the harmonize button, takes the seventh chord tone out of the mix output. So it's going to take a 4-note chord and turn it into a 3-note chord, making for a much less complex chord progression. You don't always want 7th chords if you don't want such a harmonically rich sound. So much simpler, it's just a 3-note chord. And all these controls, the waveform, voicing, inversion, have voltage control inputs. So if we get some CV happening, you'll start to hear melodic lines happening between all the voices. I'm going to take random voltage from the nanoran. It's just stepped random into inversion. So it doesn't change the tonality tonality of the chord, but it becomes infinitely more melodically dense because it's changing the inversion of the chord as it goes. So it's creating more melodies for you without actually changing the tonal center of what's happening. Take another random voltage from the nanorand into voicing. Already it starts to sound very complex, and it sounds like a lot more oscillators than it truly is because of the way that it's now voice leading through all of the chords. If we listen to each individual output, you're going to hear 4 independent melodies happening now. So what's really great about this is you can have your mix output going to a filter and you have a chord, a full dense chord, but in addition to that, you can take your root, your third, your fifth, or seventh, send it to different VCAs, and all of a sudden you have a complete musical piece happening from one single module, from one oscillator. One thing I forgot to mention actually is that, so another way to think of the harmonized mode is it's going to treat the voltage coming into the volt per octave jack as a bass line, and it's going to harmonize the chords to it. I don't think I made that point. So the fine tune knob is just a fine tune for the pitch. Just going to tune it up and down, and it's a center notch pot, so you can always get back to the value that you had originally, but you can still experiment with changing the root note. Are there any questions about the chord?
Could you conceivably do an unevenly weighted scale, like not your standard like Western scaling on that?
No, you can't. So it is tied to Western tonal harmony.
Yeah, I was gonna say like a software or like a firmware update or something like that that would allow for that kind of control.
It would be possible. Yeah, we're not planning on doing a firmware update at this time, but we'll keep it in mind. Yeah, definitely.
For the harmonized function, does it assume that the bass line is in a particular mode?
It's going to harmonize to any mode of the major scale. So
if you had a sequence in minor, would you then have to like tune the chord to the sixth?
Exactly. So if you took your sequencer and set all of your root notes of your melody to be the sixth note of the scale, then it would harmonize in minor. The chords will be the same. It'll just be where you set your root note on the sequencer.
Right.
Yeah.
Okay.
Cool. So the module we released previous to the chord is the Wave. For those of you that don't know, the Wave is a sample player. It's a 4-channel sample player capable of playing 4 samples simultaneously with extremely low latency and very high audio fidelity. Each channel can play 1 of 4 files at a time, and it has a vari-speed pitch control that goes up 2 octaves and down 4 octaves. This is channel 1, being triggered by the Noise Engineering Zularic Repetitor, which is a trigger generator. The file potentiometer here is going to switch between the 4 files that we have loaded in channel 1. The file on channel 2, we have our snare samples. And then on channel 3, hi-hat. The vari-speed pitch control has 16-bit resolution, so 65,000 steps between 6 octaves. And the pots are center notched, which allows, at the center detent of the potentiometer, you can always get back to the original pitch and speed of your file. So if you want to play things in tune, just load them in and you can always get back to that original pitch just by sending the knob to the middle position. And you always be able to feel that. The trigger inputs have a 8 millisecond latency, which is unnoticeable, nothing, yeah, faster than piano. And one of the ways that we achieve that is we load the first portion of every file into memory beforehand, allowing us to instantly go to the beginning of all the files without having to read through it to get to that point. So no matter which file you have selected on each channel, it'll always be able to play the beginning of that file immediately. A little bit of background on the Wave. There's a lot of samplers in Eurorack, and they each have certain things about them that are really amazing and unique. But what tends to be the issue in Eurorack is the speed at which you can trigger your sample and the fidelity of the audio that you get out of it. And sometimes that's desired, but a lot of the time, personally, I like to play back samples and I want them to sound exactly like they sounded when I made them or when I recorded them, etc. So our goal was to create a sample player that could actually trigger multiple samples at a time with no latency at the highest quality audio that we could achieve. So the Wave plays back at 44.1 kilohertz, 16-bit resolution. So it's just as good as anything you'd expect. It's what you would have on your computer. And the latency being what it is makes it that you can finally have a full-fledged, high-quality sampler in Eurorack. It can be a drum machine, you can play field recordings, they're going to sound exactly like they did when you recorded it and whatnot. The samples are loaded on a micro SD card at the front of the module here. There is no limit to the file length. You can have as long as your file can be as long as the FAT system allows for on your SD card. So once it's triggered, it's going to play straight through the sample all the way to the end. And if you trigger it again, it's just going to go back to the beginning of the file. Any questions on the Wave?
All right, you can load them in through the SD card, right? But how will the sampler know which file to play in which section?
So glad you asked that. Yeah. Right, exactly. So we made a Mac OS X application that is a drag and drop. You just load in all of your files and you choose which slot you want it to go in. So each channel can have one of 4 files at a time. And the application that we made has little slots that you just drag the files into, and it's going to name it appropriately. So there's a naming convention for the file on each channel, and it's achievable with this application that we have for download. In addition to the 16, once it boots up, there are 4 global banks that are accessible on the fly. So you can load in, upon boot up, it's going to play bank A, which is the global bank of 16 samples, and then there's 3 other banks that you can switch to.
You can switch to on the fly?
Yeah, exactly. So if you hold down triggers 2 and 3 for 5 seconds, it's going to start blinking, and then you just choose, you can choose one of 4 banks, which are here. So you see this is A, B, C, and D, and then it's going to blink to tell us how many files were loaded in that bank. So if we hit this one, this bank is actually an empty bank.
Right.
As was indicated by the files, yeah. So hold it down for 5 seconds, it's going to blink again, and you can go back to any of the other banks. Right. And then as you can see, it loaded up 16 samples. Yeah. Any other questions on the way?
Can you CV pick what sample it is?
Yeah. All the parameters have voltage control. You can CV between. We can take some random voltage. Let's go this. Instantaneous. Going to switch between all of them, and as well as the vary speed pitch. It's a -5 to +5 volt range on the input. So if there's no other questions, I'm going to do a short performance of the bigger system. Bye.